Good afternoon, everyone. My name is Otimong Jonathan. I'm a member of Group SWAI 02. Welcome back to my YouTube channel. I would like to brief you about our next aspect towards our project. We are now moving towards narrowing our project to a smaller aspect whereby we can easily understand it. Welcome back to my YouTube channel. You can follow me, you can like and subscribe for more of such content. So we shall start with our small content presentation. We shall have some few topics to discuss today. Introduction. We have some related work towards our introduction. We have our problem statements that are the domain and the computational problem. We also have our research questions and our objectives, and then our contributions of our research. Then the methodology and the system architecture we are going to use. The dataset description and the rest. So we shall start with a brief background. So this is our narrowed down approach to our knowledge-based reasoning for forecasting input costs, like the total input costs for our farmers, uh, especially smallholder farmers who have limited access to such tools that can help them make more accurate estimates for investing in agriculture. As we know, agriculture is the backbone of Uganda, so most of us still depend on agriculture. So, our brief background. So, our solution is to provide smallholder farmers with an AI model that has the ability to transform uh, inputs, input prices into a total cost that farmers can use to determine their agricultural plans to reduce financial risks of investment in agriculture. So, our related work, the system optimization. The system optimizes the use of data pipeline optimization techniques, which makes sure that data is implemented and validated through scripts, which ensures integrity of multiple source inputs of the data. So it optimizes the frequency of real-time price APIs, which goes to balance cost of forecast accuracy. We also use a model performance optimization, which makes sure our model optimizes accuracy and high performance towards achieving the goals of the farmers. Then we also have user experience and interface optimization. We are optimizing our user experience by making the model simple for the farmers to use, especially the smallholder farmers. We all know most of them are illiterate. So we're making sure the model is easy to use and easy to understand. That is what we mean by user experience and interface optimization. Then we shall move on to the next slide. Our problem statements. The domain application problem. Our smallholder farmers in Uganda, as you well know, face limited access to resources such as this that can help our farmers predict their total cost of investment and make sure they make uh, accurate estimates of their total investment costs in inputs like fertilizers, seeds, and other agricultural inputs that are required in their projects. So our smallholder farmers don't have that. So it leads to low yields and then financial risks of losses. So our computational problem will now be to provide an AI powered tool that will help farmers solve this problem by giving them a more accurate estimate of their initial investment costs, and they will use it to compare with what they have and choose whether to invest in that crop or choose another crop to invest in. So our research objectives and the questions that we generated from our research is to develop and evaluate a forecasting model that accurately predicts both the short and long-term seasonal prices for our key agricultural inputs like fertilizers, seeds, pesticides, and so on. We are also our objective is also to design the system's usability and impact on the target group. That means our target group is smallholder farmers. We also have to design a specified domain level agricultural graph based that takes in different inputs and provides an action oriented farm plan for our smallholder farmers. So the contributions of our project so far, we have developed a novel forecasting pipeline that distinctively combines ARIMA, Prophet, and other transformers to model both short-term and long-term seasonal fluctuations in agricultural input prices. We have also designed a one of a kind agricultural knowledge based graphical AI, which focuses on investment cost structures by explicitly encoding crop input ratios and other seasonal practices in order to provide farmers with more accurate data. Then we also are going to design a capital simulator AI model that performs scenario based investments for our farmers. Our methodology, a methodology is like the structure that the AI will follow in order to give us the predicted results. So we shall begin by testing RNBS. RNBS is the raw new business signal that the farmer submits that signal to the AI. Then the pre-processing involves cleaning and standardization of the input data that the farmers provided. Then we shall compare with the model equations which generate the forecasts and calculate the total costs of using the model. Then we shall find the index of maximum security, which compares our plan against the successful historical models. Then finding an index of the task, categorize and log the simulation with its own unique ID. So after that, we shall have our predicted result, which is the total cost that we expect to provide an insight of the snippet for the smallholder farmer as an agricultural plan.
Uh, Good evening, everyone. Welcome back to our YouTube channel. So, once of all, my name is Brian, and I'm going to walk you through the exploratory data analysis. For this case, we are going to look at the data, understanding the data, then we shall find the missing data, then we shall prepare our data sets for fitting in and modeling. So the data set description, we shall understand its data from the data sets. For this case, from our crops, we shall input prices from the seeds, from the fertilizers, the pesticides. So we find that we shall use this data and find, in case we have a missing data, we shall put in the missing data. In case we don't have any missing data, we still remove the unnecessary data. So for this case, our data had no missing data. So we had some consistency and integrity in the modeling. So visualization in our data. So we shall see our visualizations from the current data we have here. This is a distribution of input costs by variable. So here we are having the results and the discussions. We have the tables for seeds, fertilizer, pesticide, herbicide. So we have here histograms of our input variables. And here we have the labor graphs, the seed versus labor costs. Then we have fertilizer versus the pesticide costs. And our expected results, and essentially we shall have a graph of an average input costs by the region. Average input costs by what? By crop. So here we have labor cost distribution by region and the fertilizer cost distribution by crop. So according to the module that we are going to use, we chose the long short-term memory module. That's a series of time since we deal with agriculture products, the input prices, so they are seasonal, monthly, weekly, and yearly. So this is the module that we go. So this EDA prepares our data sets, prepares the data for modeling, for its modeling. Then yeah.
Hello there, my name is KD Peter Paul and I'm a second year student at Macquarie University. So I'm going to talk about the model fitting. So in model fitting, we're just trying to train a model how to use the data. You change the internal parameters of the model that so it can actually do what you really inquire and want of it. So as we chose about the long short-term memory, because plants have different timelines. So it will get information about far end and near end and short-term memories, that it can give you the best and accurate predictions of the system. So we go to the next, which shows illustrations of how these predictions will get out. So for the first one, it will be giving you the linear regression graph, which shows you the actual way the predictions will be moving on with various data within. So the system basically is using regression, so to predict the inputs and get a continuous value. So it's following patterns from very many factors. You can say rainfall, soil fertility, and weather, basically to give you the most accurate results we can get from it. So, using supervised learning, it is learning from patterns labeled data, which we have been given it, which we have been training it using. So now, when it has learned using supervised learning, it can use the following, when you give it an input, it can give you the actual based on the data I've been giving it to give you a more classic prediction. And this really shows that it's using more of weak AI, because it's just almost like a simulation of what would happen. The intelligence our system is using is naturalistic intelligence. We're talking about understanding the environment. This is agriculture, so it has to know how the flow of the nature works. That's so it can give you actually best predictions. So along the work, we found in some limitations and challenges. Some of them were having fluctuating and different prices per regions. So how are we going to have the model to understand this? So we're going to give it regional based data. So in the central Uganda, we shall know fertilizers at this much, at this price, the soil needs this. So a model will try to understand basically on where you are. So data scarcity and quality. We have a problem of record keeping. We are not sure. Farmers don't usually keep that data very well. So to solve this, we shall try to sensitize and encourage farmers to keep on keeping on that data. So the more it learns from on real-time data, the more good the predictions are. Illiteracy. For illiteracy, basically after sensitization, farmers will have a clear view of how it works. Some farmers don't have smartphones, so basically how will it work? So it can also have offline messages, SMS, that can be granted to you, that so you can know whether you're fit for the investment, as said before. So our main objective for this system was accuracy. We had a goal where we want the predictions to be more accurate. How are we going to reach there? So we went through evolutionary metrics. Basically, these are measures that you take to know how optimum the system is. So what did we choose to reach our objective as accuracy? We decided to use R square. This measures the proportion and variance dependent and gives the main goal. So it will try to learn from the data how more accurate we can get from different values and get a more accurate and critical result. So it will be basically more try to make it more easy for farmers. Since it's small holder farmers, we make it more easy for farmers to use and more of their good, something simple for them to understand at different stages. And lastly, when we are going forward, we want to build the whole system, but we want to take this moment to acknowledge Macquarie University, which has put in us to have this opportunity to share this with you. Thank you.
You're done.